Okay, here we go. We're going to do a quick example of how to solve the area of a regular polygon given two things. And each problem will be different. We're going to start with the easiest one. We're going to take the number of sides. So let's suppose we have a polygon with a number of sides of 12. And we need some other distance. So that what other distances you could have the radius, you could know the side length, you could know the apothem length. So let's do the easiest one. We'll do a radius of 7. Okay, so I can spend my time drawing a dodecagon and figuring out all kinds of different things, but I'm gonna use the KISS method and keep it simple. I know that that regular polygon can be broken into 12 different isosceles triangles. So I'm going to start with an isosceles triangle, I think. Maybe not. Let's try that again. I'm going to start with an isosceles triangle. There we go. And what do I know about that isosceles triangle? Well, I know that the radius is 7, so I know that that distance is 7, and I know that distance is 7. What I'm missing is that central angle. And I know that when I put all 12 of these triangles together, it makes the dodecagon that I'm looking for. So how do I figure out that angle? I know all those angles together are 360. There's 12 of them, so that means that each angle is 30 degrees. Okay, calculating that central angle is something you're going to do every single time. Well, now I need to know the area of that triangle. Well, conveniently enough, in this example, I can easily find the area of that triangle using 1/2 AB sine theta, because I know two sides and the angle in between. So that area is 7 times 7 times the sine of 30. So I pick up my handy-dandy calculator, and I do 1/2 times 49 times the sine of 30, and it turns out to be 12.25. Okay, so that's the area of this triangle, but that's not the question. The question is, what's the area of the polygon? Well, I know that that polygon then would be made up of 12 of these triangles. So I would take 12 times 12.25 to get the area of the total polygon to be 147 units squared. Okay, hopefully that makes sense. Now let's do another one, but we'll change the possibilities. Number one, we'll make the sides not so pretty. So let's take n being equal to 23. So we're going to get some ugly numbers. And let's start with the fact that we know the apothem is 10 units. Okay, so again, draw my triangle. Everything's going to come down to the triangle here. So there's my regular triangle, or my isosceles triangle. I know that this distance is my apothem, which doesn't seem to help much, but we'll get there in a second. And so I need to do some calculations. We're going to do the same calculation we did before and find that central angle. So 360 divided by 23 is equal to 360 divided by 23 is 15.65 degrees. I'm going to store that into x just to start. Okay, so I got that. I'd also like to know this angle. Well, that's going to be that answer divided by 5. So I'm going to store that into something else other than x, because I'm going to need multiple numbers here. So just for giggles, let's take 15.65 divided by 2. That equals 7.826. And I'm going to store that into b for no particular reason. Store alpha b. Okay, and that's in B. I got a little note there to remind me that. Well, why do I need that angle? What you notice that I'm missing is I don't have the radius here like I did in the last problem to make my life easy. So I'm going to go and find that radius. And to find that radius, I'm going to solve this nice little right triangle. I've got this being 7.826. I know the height is 10, so I'm going to do some tangent here. The tangent of 7.826 is equal to, I lied, it's not tangent. I'm not looking for that side. I'm looking for cosine, because I want adjacent over hypotenuse. So the cosine of 7.28 is equal to 10 over r. Do the switcheroo. and plug and chug into my calculator. So remember, I stored the value for the angle 7.826 into b. So when I go to my calculator, I do 10 divided by the cosine of the letter b, close parentheses, and r turns out to be 10.09. And I'm going to store that into r. So I have that when I need it. Now I'm going to take 2 seconds to look. Does that make sense? Well, yes. My hypotenuse of that right triangle should be bigger than either of the legs. Okay, now I do the same calculation I did last time. I go back to the bigger angle of 15.65, which I stored into x, if you recall. And I do a 1/2 AB sine theta calculation. 1/2 AB, so that's r squared, because remember I stored it into r, and times sine of my angle up at the top, which I will also call x. So I can plug it into my calculator just like that. 0.5 times r squared times the sine of x. And I get 13.74. And the area of that regular polygon then would be 13.74 times 23 triangles gives me 316.13 units squared. Okay, hope this makes sense, kids. Good luck. Do the best you can. I will see you on Thursday.